you look at your input today, we're going to be using inverse operations to solve two-step equations. So we know how to do each inverse operation. We've practiced using each inverse operation, the additive inverse and the multiplicative inverse. Now we just need to move forward and look at what happens when we have multiple inverse operations that want to happen. So the way I talk about this is I generally think about this idea of telling you it's like doing reverse directions. So I find a lot of times that in my car I turn on my GPS to get me somewhere where I don't know how to go. And I follow the directions, it tells me to turn right, turns me to the left, goes forward 5 miles, blah, 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 blah. And I get to my destination, and then I do whatever I need to do, and then I have to worry about getting back home. So the question is, well, how do I get back home? How do I, what if do I need my GPS? No, I don't, because to me, I go, well, all I have to do is undo everything that I just did. So the last thing I did was make a right turn. Then the first thing I need to do on my way back is take a left turn. If I went 4 miles east, now I need to go 4 miles west. And so it's this whole idea that's basically solving for the unknown. It's the same idea. Anytime that you are solving for an unknown, you're basically undoing everything in the exact opposite order. So when you're thinking about simplifying, our typical order of operations is what?
So simplifying?
Yeah, when we're just finding the value of something, our typical order of operations is what?
Just inverse. Opposite.
What is our typical order of operations? When I say order of operations, what do you think? PEMDAS. So when we're simplifying or just finding the value of an expression, we just use PEMDAS. So for things like 2 times 3 squared plus 2, that's PEMDAS. Now if we're trying to solve for an unknown, we're doing inverse operations because we're undoing those steps. It's like trying to find your way back home from a place that you've gotten to. So it's kind of like, I've started with, we can just say it, just a problem like this, 2x squared plus 3 is equal to 4. We want to do this in reverse order. So we look at all of the operations that have happened to x. I see a exponent, I see a multiplication, I see a addition. And I think about, well, the order that those would happen in is first the exponent happened, then the multiplication happened, and then the addition happened. So if I want to undo that, I start with, okay, the last thing that happened was this addition, so I undo that first. The next thing that happened was this, so I undo the multiplication. Then I do the exponent. So it's just retracing your steps. And order does matter. So we have to make sure that we're paying attention specifically to order. This first problem is one that I think many of you are quite familiar with. You've seen plenty of problems like this before. We have negative 4x plus 6 is equal to 12. So if I'm thinking about my order of operations and I'm thinking about SADMEG over here, I have two operations going on here. I have a multiplication and I have an addition. So if I'm solving for the unknown, I want to undo the one that happened last. So that means I'm following SADMEG order and I'm dealing with my addition first. So my first inverse operation is always going to be an addition if there's an addition to undo. So 6 was added. So what do I need to add to both sides if I want to do the inverse operation of adding 6? Yes, ma'am. Yes, you, Sage. Yeah, add a negative 6, so add the opposite. So once we do that, we just want to simplify what we have on both sides. So I can look in just at this here And if I'm simplifying this, I can simplify this by adding 6 and negative 6, which we know is 0. This would leave me with 4x plus 0. Or, excuse me, negative 4x plus 0. What is negative 4x plus 0? Kevin?
4x.
Negative 4x. Yeah, it's not on the page. It's hard to see. All right. Then we want to come over and simplify this side. I have 12 plus negative 6. 6. So we can see that there's actually a mistake here. So let's fix that. This should be a positive 6. So we just did that simplification. Make sure that's changed on your work. So then basically it's like we have this brand new equation, even though we've already done some work. And it's like we've basically recreated this new equation for us. Negative 4x is equal to 6. Well, this is like one of the problems we did yesterday. We have a multiplication, and that's the only inverse operation we have to do. The inverse of multiplication is what? Division. Divide by negative 4, divide by negative 4. So negative 4 divided by negative 4, as I'm simplifying this side, is 1. And 1 times x is x. And here we have 6 divided by negative 4. We could leave this as a fraction. If we did, we would just need to simplify it. So I could simplify this by dividing by 2 over 2.
3, 2.
And I would get 3 halves. Now I need to check, was this a good date or a bad date fraction?
Bad date.
It's a bad date fraction, so this should be negative 3 halves. Or we could have done the division and come out with a decimal, which would be negative 1.5. Now, 9 times out of 10 in my class, your answer is going to be a fraction. Those are going to be answer choices that are given to you. So you have to know that you can leave this as a simplified fraction. One thing I will say is looking at some of your homeworks, as I started to check your homeworks yesterday, there were a lot of people who missed a lot of problems on homeworks, the homework you turned in yesterday. And a lot of it had to do with there was no attempt to show your work the way that we were doing it in class. And there were a lot of mistakes made that way. So part of it is about getting the right answer, and then part of it's just about you have an expectation. The expectation is that your work looks exactly the way mine does. And I think if a lot of you compared your homeworks to your classworks, you would see that you were being lazy and you weren't showing the work that you were asked to. As a result, even if you got the problem right, I took off points for not showing your work right. Should look exactly like my work. There's no room for differences. Emmanuel. All right, so moving on to the next problem. Again, this one's going to look very familiar, very similar to ones you've seen before. I have the 3x plus 12. So over here I see two operations have happened, a multiplication and an addition. Again, we always want to do inverse operations in SADMAG order, so the first inverse operation needs to be revolving around this addition. So I'm thinking about, what am I going to do to get x alone? I need to get rid of this plus 12. This is extra here. So what is my inverse operation for adding 12? Emmanuel. Adding negative 12. So we add the opposite.
See, I don't get this stuff.
So here now we just want to go ahead and simplify our sides here. Here I have 3x plus 12 plus negative 12. I can combine 12 plus negative 12, which is 0. And 3x plus 0 is 3x. Now I can come over to my other side and I can simplify here. I have negative 30 plus negative 12. That is
Negative 42.
like signs add. Take the sign of the larger number. Negative 42. And it's like I have a brand new equation. So there are a lot of people who have a lot of difficulty with solving equations. And one thing that I tell a lot of them to do is to take a Post-it note and basically do exactly what I'm doing. You take out a Post-it note, you cover up half of the equation, and you just deal with that half of the equation. And make sure that you're doing the same thing to the other. For some people that works. Also, some people like to take the Post-it note and they'll do just what I'm doing here, which is cover up all of the steps previous to the one that they're working on, just so there's no confusion. It gives them just a better idea. This is what I'm dealing with now. So here I have 3 times x is equal to negative 42. My inverse operation for multiplication is
No.
division, so I'm going to divide by 3.
Yeah, you wrong.
So 3 divided by 3 is 1 times x.
Wait.
Negative 42 divided by 3 is 14. Good date, bad date. Bad date.
You're wrong because it's not a negative.
So these are the easy ones. These are the ones that you're very familiar with. The ones that are the multiplication and addition. I don't think you guys have much problems with those. However, a lot of you are not showing your work appropriately, especially on the front of your homework where it's always got this solve for the unknown problem. A lot of you aren't showing your work properly. Now that you know and we've done 2-step equations in class, there is no excuse for not having perfect work and having your work look exactly like this. If there's any guess and check on your homework, then you are not going to be able to get credit for that. All right. So over here we have an equation where we have b minus 4 is equal to negative 8. Now we have 2 operations going on here. One is a division and one is a subtraction. But we can change that subtraction to an addition. So we're going to leave change switch. That's the first step we're going to do here. We're just going to rewrite this with the leave change switch. And we know that we have 2 operations going on here with the b. So we're trying to get the b alone. I want to go in reverse order to undo the things that happen to this b. So I'm going to deal with the addition first. I need to get this negative 4 away from the b divided by 3. So what do I need to add to both sides? Positive what? 4. So we had b plus negative 4. Now we're adding a positive 4. Now if I add positive 4 to one side, I have to do the exact same thing to the other side. Now I just want to simplify those 2 sides. Here I have negative 8 plus 4. Negative 8 plus 4
Negative 4.
is negative 4.
Negative 4.
And over here on the other side, I had this negative 4 plus 4,
0.
which was 0, which just left us with the b over 3. So really right now we're working with this equation. So we've got b divided by 3. The inverse operation of division by 3 would be to multiply by 3. So a lot of people really freak out, and then this is the mistake that I saw on a lot of people's paper. They see a fraction, and they think, "Oh, I want to use the reciprocal." Okay? We talked a lot yesterday about why multiplying by the reciprocal doesn't work here. Because if I multiply by 3 over b, what happens to the b's? Kyrie? Yeah, they would cancel each other out. And that's definitely not what we want to do because our goal is to get the b alone. So we need to make sure that we're only canceling out the things that we want to cancel out. And that's our 3's. So I want to do the same thing on the other side. I multiplied by 3 over here. I'm going to multiply by 3 over here. Negative 4 times 3 is negative 12. Questions? All right. I'm actually going to skip. Actually, no, I don't want to skip this problem. Actually, yeah, let's skip that problem. Let's do this one. All right, negative 3.4 minus y. Now, this is one that is one of the second most commonly missed problems. I would say it's probably top 5 most commonly missed problems in 7th grade. So we saw the most common last unit when it came to that leave change switch outside a set of parentheses. So for this one, first thing we need to do, we want to go ahead and deal with only addition. So what do we need to do as our first step here? Justin? Yeah, leave change switch. Now, as always, leaf change switch can do some tricky things. When we get to this leaf change switch, this is not just a negative y. There's something in there that's going to be important for us to recognize. Because if we don't put it in at this point, I think a lot of us are going to find an error here. Ian. Yeah, this is negative 1y. So that tells us that this is a multiplication and an addition. In the last class, there was a lot of confusion on problems similar to this. What do I do next? Well, we have an addition to the y term. This is the negative 3.4. So for a lot of you, you get really confused because the order is a little bit mixed up. If you need to, go ahead and use commutative property and rewrite this way. All I've done here is use the commutative property to rewrite this. You don't have to do this step, but for some of you, you get really confused. You want to start adding y to both sides. Well, we don't want to add y to both sides because that's not helping get the y alone. If I move the y to the other side, then it's going to be over here with negative 5. It's still not going to be any closer to being alone. So I want to get rid of this addition, so what do I need to add to both sides here? Sunny. Yeah, so I'm going to add a positive 3.4 to both sides. So I have a negative 3.4. My new thing is I'm adding a positive 3.4 to both sides. All right, now I'm going to simplify those two sides. Looking at this side, I have the negative 3.4 and the positive 3.4. I can add those up, and I get 0. Negative 1y plus 0 is negative 1y. So here our y is still not alone, and I think that sometimes causes some confusion with this type of problem. Over here we have negative 5 plus 3.4. Like signs add or different signs subtract?
Different signs subtract.
Different signs subtract. Make sure you recognize this as negative 5.0 so you can line up your decimal places.
1.60.
10 minus 4 is 6.
1.6.
4 minus 3 is 1. Take the sign of the larger number. That was the number we put on top, which is negative.
Then I wasted 20.
Now we have negative 1 times y. It's like a brand new problem. Negative 1 times y is equal to negative 1.6. What inverse operation do I need to do now? Division. So I need to divide by negative 1. Don't want to divide by negative 1y. That would cancel out our negative 1s. Or, excuse me, cancel out our y's.
Why would we do multiplication right here if it's division right here? I don't know.
Negative 1 divided by negative 1 is 1 times y is y. And negative 1.6 divided by negative 1 is?
Negative 1.6. 1.6.
Positive 1.6. All right, and I'm going to go up and do just this one more problem to make sure that we're all on point. I shouldn't really need to tell you much about this problem. Tell me what to do first. Leslie, what do I do first? Yeah. Add negative 12 to both sides because this is going in sad meg order. There's a division here. But since we're doing inverse operations, we need to do additions and subtractions first.
Negative 6. Oh, wait. Negative 18.
So I've got like signs add. Gives me negative 18.
Put it over 1. No, you don't.
So now I'm looking over here. I have r divided by negative 2.5 is equal to negative 18.
Oh, snap.
Next step, Jalen?
And then we have to put 2.5 not over the R, but like by the R.
Yeah, put the negative 2.5 on top. And so I really like the way that Jalen's thinking about this because it sounds like he's not necessarily thinking about it as inverse operations. He's thinking, what do I need to do to cancel out that negative 2.5? So he's recognizing this is, the way to get that to cancel out is to multiply by a negative 2.5 on top. So same thing over here, negative 2.5, since it's all on top, we can just write it out.
We multiply?
So that cancels out. Negative 2.5 divided by negative 2.5, that's 1 times r is r. And negative 18 times 2.5. So I'm just going to do this down here.
Minus. 16.5. What? Oh, multiply. Oh. Boom. Boom. Cállate. No, just cállate. 45.
So I get 45. And so my answer is r is equal to 45.
Not negative 45.
Kyrie fell into my trap.
It's good thing.
I said that in that way that makes you think, hey.
It's not negative 6.
Yeah, so we have a good date. Here we have a negative times a negative, so we end up with a positive 45. Questions?
Oh. Oh, dang.
Okay, key points.
Oh, my ear.
Judea?
What?
A key point.
Who is Jabea?
He said Judea.
No, he said Jabea.
Did you say Judea?
Okay. Inverse
Shemaiah.
operation.
Okay, what about inverse operations?
Inverse. Oh, what? Oh.
What's our key point?
Sadmeg.
No.
Inverse operations in segment order. Okay.
Hush. Oh, my pop my ear.
Any other key points? Yeah, so there really shouldn't be any more key points because all we really did today was add that there were multiple steps. So what's important is that we just know what order those steps have to happen in. And so your key point encompasses that, and we should be ready to go. Please make sure that you are working very efficiently during your TA other time. This is 100% about practice, being able to catch mistakes early. So make sure that you're doing a problem, checking in with your partner. Doing a problem, checking in with your partner. Doing a problem, checking in with your partner. There should be very few people in this room who need more support than just checking in with their partner.
I'll help you.
So please go ahead and get over to your together time and get started on your work.